Personalized medicine is the ability to predict the medical past and future of an individual and to help to manage his or her health. And it seems that it will be mostly driven by genomics, and so the development of genomic technology will really help to implement it. The technology changes. We learn a lot more about the genome, the human genome, and what it means for health. Other drivers are certainly cost. Most health systems in the world now are becoming too expensive. The population becomes older, so we have to find new ways to approach medicine. And it will generally, is the hope, it will shift more from a reactive medicine to a preventive type of medicine. That is certainly one big hope, that we will be able to understand what an effect a drug would have in a person before we actually give it, so that we can possibly give drugs in a much more personalized, individual way, so that there will be less side effects. There are individuals who are known to not even react to a certain drug, so those people will probably not even get the drug, which will save money and time, of course. It's hard to predict always all the details what will change, but again, it is thought that we will be more able to practice a type of preventive medicine. So a patient will, and a doctor will have to deal more with things like risk. What are the chances for a given person to develop a certain disease, and how to react to that early? How to deal with the information in itself, how to store this information. What does this mean for the family of a person? Because genetic data have immediate impact on the family, on children and other family members. And so there is really a whole range of issues that comes with genomic medicine. I think that is probably one aspect of it, that doctors, I mean, they, in a way, today are already managing a lot. The doctors have a lot of help around them, and they already, in big hospitals, they have a kind of managerial role. But that probably will increase, and even the general physician will have more a manager role, managing the health long-term of a patient. And it's probably going to go both ways, that the patient will have much more of a say what to do about a certain situation. For instance, if there is a prediction that a certain disease might later arrive in an individual's life, then certainly that individual also will have a say in what to do about that. It's going to be a problem to how to counsel this person. Maybe not everybody wants to know about this. And if a person will learn about such a potential disease, this person understands immediately that this has consequences potentially for her or his children. So there are many aspects, from ethical to legal to very personal, that will have to be addressed. So obviously pharma is going to be part of this, and I think we see already that pharma companies understand that the times where these big blockbuster drugs were there, that they kind of come to an end. So they already look for new strategies for the future. And one strategy is, and they understand that, I think, that to look at drugs in a more individualized way. trying to understand by using genetic data mostly to kind of tailor a given drug to a patient or to a population. There might be drugs that work better in people from Asia, or other drugs that work better in African people. There are safety issues associated with drugs, and if they can be predicted, that would certainly be good for patients. Another aspect is that often drugs are today they are tested in large clinical trials, which are very expensive, and then there are always some adverse effects in a number of patients, and if there are too many of those effects, these drugs will not reach the market. But if these trials are accompanied with good genetic studies, there's a chance that some of these drugs, when combined with genetic tests, will still be able to reach the market under the condition that a certain genetic test has to be done to exclude those people where it would have adverse effects. So in fact, genomic medicine could resurrect some of those drugs that had good effects in some patients but bad effects in others. Mm-hmm. So that might be a profitable thing for pharma. Now, currently, there are about 53 drugs where we have sufficient genetic data where we can actually say genetics has an influence on how safe or how efficient that drug works. And for about 30 drugs, the FDA, that is the US American Food and Drug Administration, has actually changed the description that comes with a drug. So it includes actually now, in 30 cases, it includes relatively detailed recommendations regarding genetic data and what effects it has when you use the drug in a patient, and how you should adjust your dosage, for instance. So this is already the case for about 30 drugs. However, it's still not accepted as standard of care, which leads to two things. One is that physicians don't feel obligated to use this information. And second, insurance companies don't feel obligated to reimburse physicians if they were to use it. So these are two big hurdles still to actually use that information. But it's a first step that this information is available. And it's a little bit of a chicken and egg problem, how to move forward, so to say. In my opinion, what really will be the driver of genomics medicine or personalized medicine is applications. We need applications. We need examples of genetic tests that can help us to, for instance, decide what drug or what dosage in a given person is the best. And it should be such a good application that it really brings down the cost, so that for insurance companies it's really something they want. And then I think things will move forward. I do think they play a very important role. We have to remind ourselves these are really early days. This is the very beginning of personalized medicine. And these direct-to-consumer companies who offer genetic tests for everybody, you basically ship your blood sample to a company and they give you back your genotypes, your genetic information with some interpretation of it. Now, there have been studies that there were certainly quality issues with those in the early days with those companies. That's something that will certainly improve, I think, in the future. The other big criticism, of course, is that patients get information back, but there is no counseling. There is no expert advice. A layperson will have difficulties to understand what does this mean. On the other hand, it is very interesting to just observe how popular some of these companies are, which means to me that there is actually a broad interest in the public to explore their genomes. And some people call it recreational genomics. And I think that's largely true. It has a lot to do with being curious about one's genome. And I would think that many people maybe not really understand how deep this goes, but it's encouraging that people are kind of playful with it and are curious about it. I think that's a good sign that genomic medicine is something that will actually be embraced by the public eventually. Well, what do we need to speed up or speed up first? There are a lot of issues associated with it, and I think we generally move forward into this direction. It will happen through research making progress. It will happen through genomic technology and especially gene testing moving forward. We need IT solutions that are, that are trustful, that are easy to use. So it's hard to say what is the most important. But all of this is going forward. And of course, to implement it, we need to educate our doctors. That is a very big one. Currently, almost no medical school teaches about personalized medicine or genomic medicine. So even today, medical students don't learn about it. So at the University of Miami, we are starting next year a master's program for genomic medicine for medical students. And this is one of the few in the country, in the US. So education is going to be a big part of it. Education of the doctors, but also education of the public. So the hope is that in the beginning, probably the education will be patient by patient. But the hope is that in some future, the population becomes genome literate. Like we can read and write today, which maybe 500 years ago, there was only a minority who could do that. And similarly, I think everybody has to understand better what the genome means for a person's life.